Assalamualaikum everybody. In today's class we'll be learning how to locate irrational numbers such as root 2 and root 3 on number line. We'll try our best to cover both root 2 and root 3, but at least let us start with the first one. So yesterday we had discussed that if we have a number such as 1 or 2 or minus 2, something like that to locate on number line, it will be very easy for us to locate. But if we have an irrational number like root 2, how do we locate such number on root line? For this is a construction question, so you will have to take your compass, you will have to make use of instruments and then do the construction. So let us learn how to locate root 2 on number line, but before that we need to have some knowledge about something called as Pythagoras Theorem. So we'll discuss what is Pythagoras Theorem first, and then we will come to how to locate root 2 on number line, because this plays a very important role in understanding how to locate irrational numbers on the number line. So Pythagoras was a very famous mathematician and he introduced something called as Pythagoras Theorem. He gave a very important proof and therefore the theorem is called as Pythagoras Theorem. Now what is Pythagoras Theorem? According to Pythagoras Theorem, if we have a right angle triangle, and what is a right angle triangle? A triangle in which one of the angles is exactly equal to 90 degree. Example, if I have a triangle ABC and if angle B is exactly 90 degree, then this triangle will be called as a right angle triangle. So in a right angle triangle, he said that there is a side called as hypotenuse. So basically there are three sides in this triangle, right? AB is side number 1, BC is side number 2 and AC is side number 3, or you can tell it in any order that you want. So hypotenuse is the largest side of the right angle triangle, and in this case, to understand in very simple terms, whenever you see a right angle triangle, slant side, the ladder type, right? So the slant side always represents the hypotenuse side. So we'll call this as hypotenuse. So if I take this as the hypotenuse or the slant side in Pythagoras Theorem, then there will be two more sides remaining. Which are those two more sides? AB and BC, isn't it? So according to Pythagoras Theorem, the square on hypotenuse, what is our hypotenuse here? AC. Square on hypotenuse will be equal to the sum of the square of the other two sides. That means you should take square for all the three sides. AC square, AB square, BC square. So after you take the square on all the three sides, you should take the square on the hypotenuse side. That will be equal to the sum. Sum means addition. Addition of the other two sides with squares. The other two sides remaining are AB and BC. So this will become AB square plus BC square. In 10th standard, you will have one complete theorem called as Pythagoras Theorem along with proof and problems. But in 9th standard, it is enough if you know this much, that Pythagoras Theorem is used for something like a right angle triangle only. You can't use it for any other triangle. Along with that, you should remember that there is always a slant side called as hypotenuse. Hypotenuse is the largest side in a right angle triangle, and that largest side is called as hypotenuse. So this hypotenuse square, whenever we speak about Pythagoras Theorem, we should take square on every side. So which are the three sides? AC, AC will become AC square. The other side is AB, AB will become AB square. BC, BC will become BC square. So once you take the squares on all the three sides, the hypotenuse or the largest side, the square on that side will be equal to equal sign the other two sides, the sum of the square of the other two sides. Which are the other two sides? AB. I had said take it along with square, so this will become AB square and this will become BC square. So you have to add the other two sides, that is AB square plus BC square. So please remember Pythagoras Theorem along with right angle triangle and its mathematical statement. So to understand better, let us try one more. Let us suppose I have a right angle triangle called as PQR and it is 90 degree at angle Q. How do we write Pythagoras Theorem for this? Which is the hypotenuse side? PR. So it will become PR square equals to, which are the other two sides remaining? PQ and QR, and I should take take squares along with them. So PQ will become PQ square plus, what is the other side remaining? QR square. So you don't have to worry in 9th standard about how did we get this, because in 10th standard we have a complete proof on telling how should we get this answer or how should we get this equation. Right now just remember how will you use Pythagoras theorem for any right angle triangle. I repeat, you'll have to take the hypotenuse square or the slant side square equal to then the other two sides along with the squares and just add them. I hope you have understood what is Pythagoras theorem. Please send me any doubts that you have so that I can clarify you about Pythagoras theorem once more on our Google Classroom app. So now coming to how to locate root to a number line, because we have learned Pythagoras theorem, it is going to be helpful for us in locating root to a number line. Let us suppose I have got a number line. I'll take 0, then I'll take 1, then I'll take 2 and so on. I can take like that. So, and I don't need negative integers here because it is a positive root. So I don't have negative sign before root sign, so there is no need of taking negative integers. So what I have to do here is, when I draw this number line, I'll have to be little careful about few things. One, the distance between one number to the other number has to be same every time. Example, when you take your scale and if you are leaving a gap of 2 cm here and writing the number 1, then before you write 2 also you should leave a gap of 2 cm only. Randomly don't write, simply don't write 0, 1, 2 like this. Please keep fixed distances between each number, right? If you are keeping a distance of 2 cm here, it will be 2 cm here. 2 cm is an ideal distance to keep. So what we'll have to do is, I'll call this point as A and I'll call this point as B. Is that okay? So I'll make this line or this distance between A and B little darker. So then what I'll do, I'll take the compass, I'll take my compass and I'll keep the compass pointer here, the needle of the compass here, and measure up to B. I'll measure the distance from compass from A to B, and then I'll keep the compass here, and with whatever distance I have got exactly I'll keep here with pencil. I'll make a mark here like this, and then I should join this. So this distance and this distance is going to be same. I'll repeat the step. We have drawn a number line by writing some digits, and I have also made sure that the distance between every number is same. Now I'll have to take compass, measure this much. I hope you know how to make use of compasses. We've learned it in 8th standard a lot of times while doing construction. Then keep it at B, just make one point here and then join this and call this as point C. Is that okay? Now take your scale and join it up to C. Take your scale and pencil and join AC. Have you understood up to here? Step number 1, AB. Then take compass, measure this much, keep the pointer at B, mark exactly with pencil here, just keep a dot also if you want, then join B to C, and after that is over, join AC. Don't you think this has become like a triangle now? It has become a triangle, isn't it? And what kind of triangle it has become? It has become a right angle triangle, because this is equal to 90 degrees. Right? So a right angle triangle can look like this, or a right angle triangle may also look like this, which is fine. But what we want is, we want one exact 90 degree. So once that is over, let us try to apply Pythagoras theorem. But okay, before coming to Pythagoras theorem, let us finish off with the construction. So now I have to take the compass and keep the pointer, the needle of the compass here, and take my pencil up to here and measure this distance. Okay? Is that okay? So I'll keep the compass here, the needle, and measure up to here. And what I should do is, when the pencil is here and the pointer is here, I'll have to cut an arc like this. So I'll imagine like this, and I'll cut an arc. Complete arc I should cut. So compass is here, pencil you will drag up to here with your compass, and just keeping at this point C, you will cut an arc, and this will be the value of root 2. Okay, this is how we locate root 2 on number line. That means this position on number line will be the position of root 2. So this we took as 1 unit, because from 0 to 1 it is 1 number, and if this is 1, this distance is also same, right? This is also 1. So this answer should be equal to root 2. And how do we prove that this answer AC is equal to root 2? By making use of something called as Pythagoras Theorem. So I have got a triangle here which I will draw again to understand better. So this is C, this is B, and this is A, 90 degree at B. How do we apply Pythagoras Theorem? Which is the hypotenuse side? AC. So it will be AC square is equal to, which are the other two sides? AB square plus BC square. Now AC square is equal to AB. AB is 1, right? Because we just took distance of one number, it will be 1, then there will be square. Plus BC. BC is also 1, right? Because if this is 1, same distance we took here also, that's why it will be 1. AC square is equal to 1 square means 1, 1 ones are 1, plus again 1 square is 1, 1 ones are 1. AC square is equal to 1 plus 1, 2. Now AC is equal to, whenever you shift square on the other side, it becomes root. Just like if I have plus on one side, after equal sign if I shift, it will become minus. If I have minus, it will become plus. Like that, there are so many transformation rules. So similarly, if I take this square on the other side, it will become root. So this square that was here, that got shifted here. So this square became root. So the value of AC became root 2. That means AC is root 2. This we are supposed to prove by making use of Pythagoras Theorem. I don't have the instruments with me here at home now. That's why I'm just doing it very roughly, but you will please make use of all the instruments and then do the construction. Before ending today's class, I just revise what we have done to locate root 2 on number line, and in tomorrow's class we will see how to locate root 3 on number line, and then we have one more question of root 5. They are easy. Once you learn this, the other two questions will be easy. How to locate root 2 on number line? Step number 1, we draw a number line, and then we write numbers with fixed distances between each number. Then we just take 1 from 0 to 1 as 1 unit, and then with the same distance I will measure with the help of compass, keep it at B and make a point here. The distance from here and the distance here should never change for when you are locating root 2 on number line. Once that is over, what should we do? We'll take our scale, join AC, then we'll take compass, keep the pointer of the compass here, drag the pencil up to here and cut an arc. And that arc will represent the location of root 2 on the number line. Now I should prove that AC is also root 2, and to do that I will have to use Pythagoras Theorem. I have got one right angle triangle here, and this triangle I will draw, and we have seen how to use Pythagoras Theorem. This is the hypotenuse side, that is the slant side. AC square will be equal to the other two sides, AB square plus BC square. So AC square is equal to, the value of AB is 1 here, because we have just taken 1 unit. So 1 square plus BC, because if this is 1, this is also going to be 1, it will be 1 square. AC square is equal to 1 square is 1, 1 square is 1, because 1 ones are 1, 1 ones are 1, and 1 plus 1 is 2. If I shift this square on the other side, square becomes root. So the value of AC will be root 2. Please reach out to me if you have not understood or if there are any other doubts. I will help you clarify with some other methods if possible. And in tomorrow's class, let us see how to locate root 3 on number line. Thank you for watching the video.